Alright, hello and welcome. So in this problem we're going to do an example of exponential decay. Right? So we're going to use the same formula as in the last example, but you'll see that k will end up negative. Okay, so let's read through this. The half-life of radium-226 is 1,590 years. So radium-226 is just a chemical substance. It's radioactive, so it decays. That means over time it loses how much radium there is. It basically transforms into another substance, right? So half-life means that it takes this many years, it takes 1,590 years in order to get half of the amount of radium that you started with, right? So how much of a 100 milligram sample would be left in 500 years, okay? So let's see, we're going to start with this equation right here. So we're going to do this in two parts. The first part, we're going to find what the k value is. So k equals something, okay? So we're going to use this first sentence, this information. Okay, so if we start with 100 milligrams, then I know that it takes 1,590 years for the half-life. So it takes that much time to get to half of this initial amount, which is 50. Okay, so we have this equation, and we can find what k is. We can find what the decay constant is. So we're going to divide by 100. We have 1/2 equals e to the 1,590k. Now we take log of both sides, cancel out the e. We have log of 1/2 equals 1,590k. Divide by 1,590. We get k equals some number. Let's figure out what it is. Okay, so calculator time. Alright, so log of 1/2 divided by 1,590. Oh, we went in the wrong place. We need to be on the outside. Divided by 1,590. Wow, okay, so this is like negative 4.359 times 10 to the negative 4. Negative 4.359 times 10 to the negative 4. Okay, this is scientific notation. We're going to write this. Negative 4 means you move the decimal 4 spaces to the left. So it's going to be negative 0.0004359. It's pretty small. Slow decay. Alright, now part 2, we're going to go back to this equation and see what it says. How much of a 100 milligram sample will be left in 500 years? We've got to figure out how much of this, if I start with 100 milligrams, and now I know the k value is negative 0.0004359 in 500 years, times 500. Okay, so we're going to put this in the calculator. Alright, so we have 100 e to the power, parentheses. We're going to put the previous answer in. We can copy it over. Times 500. We get 80.4. So A is going to be 80.4 milligrams. Alright, so still a lot left after 500 years. As I say, it's slow decay. Alright.